Hello everyone, my name is Neha Kartham and this is the sixth lecture on Introduction to Microcontrollers. In this lecture, we are going to learn about how the program execution takes place in big mid-range microcontrollers. So let's get started. So this slide basically talks about an exercise which you have done in the class, and it's about the robot program. And you can see this is the algorithm for that, an example in which you can see these are the steps. So this says like to move forward and then take left, move forward 10 centimeter and then take left 90 degree and then further take left 90 degree and then reverse 10 centimeter and then right turn 90 degree. So this represents your algorithm. And then these 1, 2, 3, 4, 5, these are the sequence and they are basically put on the first column. And you can also say that these are your labels. And then instruction in the second column. So we learned about this. In our case, you can say this is our mnemonics. So we should be put in the second column. And then third is the operand. So all these numbers which we see here, these are put in the third column, and these are called your operand. Now moving forward to the next slide. So here we have our code which I have put here, and you can see in this code we have 3 columns, and now you know that the first column represents your label, second column is for mnemonic or operator, and the third column is for operand. Now if you look at the code, then you will see that this label blink 1 and delay has been called in the program. So these labels you can call into your program. So for example, this blink 1 has been called here under blink 0 label, and you see this delay has been called here under blink 1 label and under blink 0 label. And so what happens, so as you go through the as the system it executes a program, and it reaches to this delay point, then what will happen, it will jump to this delay and then it perform all these operations, and then it will go back to this instruction. Okay, and then it will perform all these operations, and then you have this delay over here, and then it will go back to the delay again, perform all these operations, and then go to the next step, which is your go to blink 1. So go to blink 1, so it will go to this blink 1 and perform all these operations again. So you understand that the usefulness of the labels and how they can be used in your operation, and then you can repeat the whole operation based on your code design. So like I said before, these are called your labels, which identifies a section of a code, and then this is your operator or mnemonic, and this is your operand. Now a quick definition for labels can basically be anything we want. More important, they allow us to go to a section of our code to reuse it or to loop to a location. So for this particular example, you can see that in under both label we have like a delay, and this delay is kind of going into a loop. Okay, so yeah, that's what it says, and label 1, and then here we are going to go to the section of the program. It's the same thing which I've told you. The instructions are what the microcontroller is actually going to do. So these are the instruction set you can say for this particular program. So each of them has its own meaning, and you can understand the instruction set through the data sheet. It basically shows all of the instruction set for your microcontroller, and it also provides some examples to see how it works. So for example, in this particular case, the first instruction set is move LW. So this move LW means move the literal number to the W, where W is the working register. So move the literal number to the working register, which means this is our literal number 0 cross 01, which is in hexadecimal, and it is asking to move this hexadecimal number, which is called your literal number, into the working register. So we will learn about how the program goes in the next coming slide. So this is your literal number, as I said, 0 cross 01. So what does this 01 represents? This 0 represents, let me use the pen. Okay, so this 0 represents 0, 0, 0, 0, 0, 0, 0, 1. This is what it represents. Now moving on to the next slide. So pick mid-range instruction set. So the development tool which we are using, it has a PIC 16F18875 microprocessor, and it uses around 49 possible instruction sets. But there are some microprocessors and microcontrollers which have like more than several hundred instruction sets. To learn about the instruction set, you can go to the data sheet, and it shows all the instruction set for this particular microprocessor, and it also provides some examples to how to use them into your program. Now what we are going to do is to learn about the hardware, and we will understand a little bit about how it makes sense to the instructions. And instruction set we are going to learn in later in our lectures. Okay, so let's move to this slide. On this slide you see we have a control unit, and then we have a working unit register. We have a memory bank 0, memory bank 1. So let's understand what each of these means. So this control unit which you see is it basically represents the instruction, and it interprets the instruction and it executes them. It has several other functions also, but we are going to learn that later. So for now, just understand this control unit is the main unit which interprets the instruction and executes them. And then you have this working register directly connected to this control unit. So what happens to this working register is that in this working register you will the information is basically placed to be worked on by the main core processor, and the results of instructions can be placed here as well. So you can say that if you have a code you're working on that, then that information is basically saved into this working register. And then memory banks are used. They are more than just a memory, and many of them serve as controls for the microcontroller. So you will be using 2 memory banks. Some of the microprocessor, they have like more than 2 memory banks, and these memory banks, let me show you in the second slide. And this is how it looks like. So this is memory bank 0. You can see it has all these different registers, and some of those registers, they have like specific function. So this is your memory bank 0, and the other one which you see here is your memory bank 1. So 0 and 1, and this also has the same thing. All of these are registers, and they have specific meaning. So let's say Microchip has made it easy for us. We can talk to the register with either its name or its address. So for example, port C. So this is the name of the register, and 07H is the address. So you can use either the address of this particular register, or you can use the name of this register to use it into your program. So port C has both names. Port C is the name and the address is 07H. It's in hexadecimal. Uh, so so you understand that you can use both the names, any of these names, to call into your program. So you can think of this names as this example. So we can say I'm going to the Lake Washington Technical College, or you can say I am going to this particular address. They both mean the same thing. Whichever is easier, you can use. So usually we use the name because that's like more easier rather than the whole address. Now we will look at our instructions and how they work in the PIC. So let's begin with this example code which we have used. So you see we have move LW. This particular instruction set means moving the literal number to the working register. So what is happening? This literal number is going to move to the working register. So you can see here in this example that this literal number has been moved to the working register, and the next operation says that move WF, so which means move the working register, whatever is there in the working register, to the F. F is the file register. So move the whatever is there in the working register to the file register, and which means file register is port C. So in this based on your code, it wants this number to be saved into port C. And if you go back to our previous slide where I talked about the banks, so you see that this port C lies in bank 0. So which means we have to select one of the bank. So we are going to select bank 0 because we know that port C lies in the bank 0. So bank 0 is selected, and then the literal number is moved to the port C. And then you have call delay. So it is going to jump to this delay. Okay, and then it will execute the instructions from here, whatever is put over here. So let's say it has moved literal number to the working register 0 cross 80. So it is going to move the literal number 0 cross 80 to the working register. So this is a little bit programming I showed you, and how it works and how the instruction flows in the microcontroller, and we are going to learn about this more in the next coming lectures. So this is the end of the lecture. Thank you so much for watching.